Okay, beautiful people. So we're going to do some quick guided notes on everything coordinate plane. And as we're working through this unit, a couple of things that you need to be aware of and make sure that you're practicing is being knowledgeable of the locations of everything and how your coordinate plane is set up. So we're going to start by just taking this basic piece of graph paper and setting up the X and Y axis for this. Now, on a coordinate plane, when you move to the different quadrants of the coordinate plane, you always start with X, and X is the horizontal axis. Y is the vertical axis. Now, with X and Y, up until fifth grade, you were doing only things in this one quadrant, which would be positive X, positive Y. But now we're doing all four quadrants, so we're dealing with positives and negatives for all four quadrants. So on X, the right side is always positive. Now I'm just going to do these in different colors so that you'll see the left side is always negative. For Y, the top is always positive and the bottom is always negative. So 0 is your origin. Everything to the right of 0 is positive. Everything to the left is negative on the x-axis. For the vertical y-axis, everything above the 0 is positive. Everything below the 0 is negative. And in each of our quadrants, we have to pay close attention to what the signs are. For this, the quadrants are they go counterclockwise in the numbering of them. In the first quadrant, I'm going to do this, which is Roman numeral 1. In the first quadrant, my coordinates are always going to have a positive x and a positive y. Now, you always put your coordinates in a set of parentheses because those go together. It names one location, and only one location can be named by each set of coordinates. So quadrant 1 is positive, positive. Quadrant 2, in this one, you would go left, negative x, and up, positive y. So negative x, positive y. In quadrant 3, you would have negative x over to the left and down, negative y. So this would be negative, negative. A little bigger. And in quadrant 4, you would have a positive x because you go to the right, but you go down, so it would be a negative y. So this would be positive x, negative y. Now, in looking at these and being aware of all these, if you're having different points on the plane and you're moving to different locations, if you have an understanding of the positive and negative signs, you can find things like reflections and distances between points by looking at the coordinates and finding the difference if they're in the same quadrant, or adding the absolute values if they're in different quadrants. Or you can plot them and count them. It all depends on how your grid is set up. You know, it could be fractions, it could be decimals, it could be whole numbers. And when you're working with positives and negatives, of course, distance is always in positive, but you want to make sure that you are adding the absolute values if you have points into separate coordinates, and subtracting if you have the same coordinates. Now, for starters, we're going to go ahead and make a couple of notes on here. And I want everybody just to write everything down just as we're doing it here. But I want you to be aware of a couple things. Anytime you are reflecting across the x-axis, to reflect across the x-axis, you would have to move vertically up and down. If you are reflecting across the x-axis, then the y value will change. The y value changes when you reflect across the x-axis. And likewise, when you reflect across the y-axis, now to go across the y-axis, remember y is vertical. To cross the y, you would have to go side to side, and moving side to side, the x changes because the x is the first value or the first movement that you make on the coordinate plane, and it is always side to side. So if I go side to side across the y-axis, then the x value changes, okay? And I know that looks small, but hopefully you can see that. Now, additionally, if we're looking at points, let's just put a few points on our coordinate plane here just so that we can kind of work with them. I'm going to plot my points in like a dark purple color so that they'll show up. Now, this is a standard 1x1 grid. 4 blocks is 1 inch. And I'm going to do, each block is going to be like 1 unit. So actually it would be layered in force. But if I were to number this, I could have specific points. I'm going to just put points on and plot them. They're not necessarily going to be marked on the grid just because I don't have a whole lot of space. But I'm going to put a few points, and I'm going to identify things like their distance between points, reflections, that kind of thing. Okay. Let's see. Is that right there? I think it is. Okay. Let me make that a little better. All right. So these are all in line. Now this looks like it might be a perfect square, but notice both of these points here and here are different distances away from the y-axis. Notice that both of these points are different distances away from the y-axis. So we will take that into consideration when we're graphing and recording these, because we have to see and know what each one is. Now, for example, in this quadrant 1, I know it's going to be a positive, but I'm going to label this coordinate for the x is going to be 1, 2, 3, 4. The y is going to be 1, 2, 3, 4. So this coordinate is 4x and 4 for y, both positive coordinates. For the point that lines up with that is below the x-axis, it's going to have a different, it's going to have the same x value because it's just the same distance over, but it's going to have a very different y value. So if this is 4, 4, then this is over 4 down 1, 2, 3, 4, 5, 6, 7. This point is going to be 4, 7. And remember, it's an address, so you always put that in parentheses. And looking at what we have, the distance between these points from the x-axis to this point is 4 units. From the x-axis to this point is 7 units. So to find the distance between these 2 points, I'm going to take, let me turn it this way, the absolute value of both of these combined. Now, technically, you're subtracting to find the difference, but that's going to be not a 7, that's a -7, Jennifer. Let me fix that. What did I do with my pen? There it is. That's 4, -7. I made that mistake and didn't put that on there. So 4, -7, and 4, 4. Now, I'm going to look at the absolute value of these distances from here to here. We have the absolute value of -7. From here to here, we have the absolute value of 4. And if I take the absolute value of -7, that is 7, and 7 plus 4 is 11. So the distance between these 2 points is going to be 11 units. If I have, and if you set it up like a difference, you're going to take the absolute value of the total operation. And this is going to look confusing, but I'm going to put my operation in this absolute value signs. So that would be 4 minus a -7, parentheses closed. Now, notice that the operation is inside of that. You're going to perform the operation inside and then take the absolute value of that. But in essence, this is the same value as if I were to take the absolute value of 4. I need to do that in a different color. if I were to take the absolute value of 4 and add that to the absolute value of negative 7, and that would be 11. Now, looking at the way that the unit is taught, if you remember last in module 3 where we were doing the opposite of the opposites, and in earlier lessons where we were talking about positive and negatives, if I have a negative 7 and I have a negative sign outside of it, that means I'm taking the opposite of negative 7. So instead of subtracting 7, that would be the same thing as adding 7. So 4 plus 7 is going to be 11. If I combine that, if I have that, the absolute value of that is going to be 11. So it's going to be the same. For me, it's easier to just add the absolute values, but I wanted to show you this because that's how your book is going to do it. Now, let's talk about the points that we have here and the distance between them. We know that this is 11. So also on the other side, this is going to also be 11. So this side is 11, this side is 11. If I look at the points here, moving across the y-axis, this is going to have the same this is going to have the same y value of 4, but notice the x value, it's a different number off the axis. So I'm going to count over 1, 2, 3, 4, 5, 6, 7. So this is 7 away from the x-axis. Let me double check that. 1, 2, 3, 4, 5, 6, 7. And it is also going to be 4 up for the y value. Oh, I did that wrong. My brain and my mouth are not working together. I'm thinking one thing, writing another. And when we look at this, this is going to be negative x, so negative 7, and positive 4 for my y value. So the location of that point is negative 7, 4. Now, also this point is going to be the same distance away from the y-axis. So your x on this one is also going to be negative 7. But notice that that is a different distance away. It's going to be, in essence, the same as what you had from here to here. The negative 7 is our y because we're coming off the x-axis, but we're still 4 units off. So that point down there would be 4 for the x, negative 7 for the y. Okay. Now, additionally, and I'm going to change this color slightly. Since these two are equal, if you look at what I have here, I have, in this one, I have, that's a negative 4. And that's one, no, that's going to be 7, 7, not negative 4. What am I thinking? I'm not even counting lines, y'all. I don't know what's wrong with me today. This is going to be a negative, negative. So this point is going to be negative 7, negative 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And it's a reflection of this point. Now, notice, because I'm moving side to side here, my x value is going to be different, but the y value is going to be the same. To find the difference between these points, I would take the absolute value of negative 7 plus the absolute value of 4, and 7 plus 4 is also 11. So I've got the absolute value of negative 7 plus the absolute value of 4, and that's going to give us a distance also of 11. So this is actually a square figure, which means I could use these values to calculate the area, or I could use these values to calculate the perimeter. Now, we talked about reflecting across the axes and how the y value and the x value changes. using this same thing with the polygons on the coordinate plane, once you know how many points are, or how many values are there, you can calculate things like perimeter, area, and you can use whatever formulas for whatever shape. So in this one, my figure is 11 by 11. And we know for area, and I'm just going to write this over here, area equals length times width. So if I have 11 times 11, I think that's 121. Let me check my brain because it is actually 7:30 in the morning. Yeah, it is 121. So that's going to be 11 times 11, and that's going to be an area of 121, whatever the units are, squared. Okay. The perimeter would be 11 plus 11 plus 11 plus 11, 2 times the length plus 2 times the width. So the perimeter, which is the distance all the way around, is going to equal the four sides. So 11 plus 11 plus 11 plus 11, which is going to be 44. Or you could do the 4 times 11, 4 times the sides that are 11, and that's going to be 44 as well. Now, a couple of things that I want you to write down. If you have if you have a situation where you're calculating the distance between points, or you are looking at how you would determine the side lengths to make whatever formulas for perimeter or area, a couple of things you need to know. I need a different pen for that. I want something that shows up better. Okay. Write this down with that. When you have values that are in the same quadrant, so I'm just going to put like a little note here. So write this down. For values or for points, let's say for points in the same quadrant, points in same quadrant, for points in the same quadrant, you will, let me focus this. You subtract to find distance between. All right. If you're subtracting to find the distance between points, of course, you can subtract and do it the weird way, like this shows here, but it's easier for me if I have points that are in different quadrants. So for points in different quadrants, quadrants, you add absolute values. That's the distance away from the axis, the X or the Y axis. You add the absolute values. So to find distance, or find the distance. And let me just show you an example of that with some of the points that we already had. Let's say that in the same quadrant where I have the things in each quadrant, if I wanted to plot a different point, let me use a different color here because I got my other points in purple. If my other point that I have is, let's say, still at 4, but I have it a few units above my original point of 4, 4, that point is still going to have X as 4. but it's going to be 5, 6, 7, 8, 9, 10. This point is going to be 4, 10 for its location. Now, in looking at this, you look at the points that are actually different, and then you are going to subtract to determine how far those points are away from each other. So in looking at this, if I have, this one is 4, 4, this one's 4, 10. So the difference is in the 4 and the 10. So the distance between this point and this point is going to be reflected in the answer of 10 minus 4, and that's going to be 6 units away from each other. So 6 is how far this is from that, okay? And you could do that either way, but in order to find the distance between points, remember, you're looking at the values that are different, not the ones that are same. You know, they're both, the x is 4 in both of those, so I'm looking at the y because it's higher. If I had a point that was, say, more to the right or even to the left, let me just put one over here. If I had a point, say, that was right here, now that's going to have the same y value, but notice that the x value on that one is different. So for the x, if that's 4, 5, 6, 7, 8, 9, 10, 11 is going to be my x, and up 4. So this point is going to be 11, 4 in parentheses, because remember, that's the address of that point. And I would look at what is different between this point and this point, and I would subtract 4 from 11. So the distance between this point is going to be, let's see, and you could count over or you could just subtract, but I know that 11 minus 4 is 7. So the distance here is going to be 11 minus 4, and that distance, that pen is rotten. That distance is going to be 7 units. So 11 minus 4 is 7. So from here to here is 7. From here to here is 6. From here, the x-axis to this point is 10. What if I were to do from this point to this point? I have a 10 and I have a negative 7. If I was going from this point at the top to this point at the bottom, it would be the absolute value of 10 plus the absolute value of negative 7. So 10 plus 7 is going to be 17. So from here to here is 17 units. Now, I know that these notes, with all the colors and all the different points, it looks a little bit confusing. But when you're thinking about all the things with what we can do with the coordinate plane and all the things with how it's set up, as long as you have your signs correct and you know which quadrant the things go in or which quadrant the points go in, and you look at the difference in the coordinates, you can tell which axis it would reflect across, how far the points are across from each other. And this is using everything that we've used with positive and negative numbers, all the rational numbers, fractions, decimals, regardless, no matter what, you could graph that on a basic coordinate plane. And I hope this helps, and I hope this gets us situated so that everything that we're doing will, oh wait, I got one more thing I need to talk about, and I forgot about this. If I have a value in my coordinates that is 0, let's back up a little bit. If I have any value that is 0, okay, so for 0, and this is important, for 0 coordinates, for 0 coordinates, ATES, for 0 coordinates, the 0 value or the place of the 0 value means that it's going to be on that axis. So you're only going to have like your X or your Y. So for example, if I have the coordinate, well, let's just use 5. If I have X is my 0, 5 is my Y, for that, my X, I'm not going to be moving side to side. So that is actually going to be on the Y axis. Okay. If I have same thing, but the Y is the 0. If I have, say, the point is 5, 0, then that point is going to be located because the X is over. No, wait. Yeah, that's going to be located on the X axis. It's backwards and you get it mixed up easily. And I'm going to just show you, this is how I address this for all of my 55 years. Actually, I've not been doing this 55 years. Let's take 10 away. For all my 45 years that I've been doing this, I always find it easier to draw just a little basic coordinate plane for all of the things that I'm doing. And if I have the 0, 5, it's going to start at 0 and it's going to go up 5. And that clearly is going to be on the y-axis. If I have 5, 0, that is going to be over 5, my y is 0, so I'm not going up or down. So that's going to be on the axis as well. And if you draw and have like a little shape or a little basic coordinate plane, you can kind of plot and decide where those values are. I hope this helps. The next time we do this, we'll talk about finding the distance with just the coordinates when we don't have a coordinate plane, but always make sure that you have paper or something that you can write on, just so that you can have your little clues and things to sort out and find the difference between all of your points, okay? And I'm going to stop this now. I hope this helps. And I hope that I didn't say one thing and write another, but my brain works that way sometimes. So forgive me if I sound like a dingbat, but I hope this explanation helps you all.